Good day everyone, I am Sean Krill Kaminade and I am here to present my EplanE. So at the scenario description, at 10:30h, the ship is on course at 225 degrees true bearing with 10 knots. With the use of visual method by the OOW, he observed that Agio Point Lighthouse, which bears 0.25 degrees relative bearing, after an hour, the same object was abeam to starboard. So we all know that a beam is equivalent to 90 degrees. So in order to solve, we must find Agio point. Agio point is located here with a relative bearing of 0 to 5 degrees. We must first convert it to true bearing. So in order to find its true bearing, we simply add 90 degrees from its abeam with 25 degrees relative. So the answer would be 115 degrees. That would be its true bearing, 115 degrees. Now we must find the course of the ship. So the course of the ship in the scenario description shows it is 225 degrees. So, going with our ruler, excuse me, let me do this. In the ruler, I must search for 225. 225 would be located around here. Yes, this. Simply go to the middle of the compass repeater. Then put the course around here. So that would be the hypothetical course of the vessel. Now, in the first part, at 10:30, the ship is on course. He observed Agio Point, which means that Agio Point would be at the side of the ship since it is just visually directed. Let me use my other ruler to see Agio Point. Possibility of the course. This would be our first location or our first fixed point, which would be 10:30 hours. Okay, 10:30 hours. Now, after 1 hour, the same object was abeam to the starboard. So, meaning the vessel, after 1 hour or 60 minutes, the vessel would be ahead and Agio Point would be abeam to the starboard. Now, in order to search for it, for the location first, I must solve, pardon me, getting a new paper. I must solve the formula of distance, which I do not know. So I must use the time, which would be multiplied to the answer of the addition of the hours, which would be 10:30, 1 hour would be 11:30. So 11:30h, pardon me, it's subtraction, not addition, minus 10:30h. So the answer would be 0, 0, 0, 1. The answer would be, for the time, 01.00 or 1.00. Since we are looking for the distance, multiply it from the course. This is time, this would be the course. I am mistaken earlier. So the course multiplied by time, this would be time right here. Course multiplied by time, so the course would be 10. Since it says here 10 knots. 10.0 multiplied by 0.10, meaning it would be the same as 10.0 nautical miles. Yeah, nautical miles. Meaning, I must locate 10 nautical miles in order to find the second point. Using my compass, in order to locate, I shall find 10 nautical miles in the chart in order to locate the second point, which would be this, around here. Yes, around here. So this would be my second point, or 1 hour later, 11:30 hours. This would be the second location of the ship, which agio point would be at the beam to the starboard. Pardon me. And next, locating the longitude and latitude. In order to find the longitude, I must create a hypothetical line in order to find the location easily for both points of the vessel. So both points of the vessel would be simply like be created the line around here. Now, solving it would be a lot easier now that I have the imaginary lines to assist me. So the latitude of 1030 would be, let me write it here, around, it's 10 degrees around here, so it would be possibly around 9 degrees. 09, 40 minutes, 09 degrees, 40 minutes, and 3 seconds north. The longitude would be around here, locating at 125 degrees east, so 124, since we are below the grid lines of 125 degrees. 124, around 40 minutes, and 3 seconds east, since it is east. Now, the second point would be located around here. The latitude would be still the same, 09 degrees, around 20 minutes, 2 seconds north. The longitude would be around the same, since still 125 degrees and we are below 125 degrees grid line. It would be 124 degrees, 20 minutes, and 2 seconds east. So we have located the first point, 10:30 hours, the second point, 11:30 hours, and have converted the relative bearing to true bearing. That is all. Thank you.